Hello, friends. Do you dream of your own house? Wondering if it's possible to build one yourself with a limited budget, no experience, but plenty of enthusiasm? Then welcome. We've practically completed the house, have been living in it for several years now, and will share our story with you. Additionally, we will describe the entire construction process from A to Z. So, after buying the plot at the end of summer, I had the entire winter to design my house. A ready-made project didn't suit me, so I drew my own after reading a bit about space planning, furniture arrangement, etc. The main task was to create a comfortable living space, but one that was structurally simple, inexpensive, and warm, and I succeeded in doing that. Our house has 2 full floors with a total area of 105 square meters. The first floor consists of common rooms, living room, kitchen, utility room, etc., and the second floor is a relaxation area, 3 bedrooms and a bathroom. After living in it for a few years, I can say the house is very convenient and practical. A more detailed description of the project is already available. The link will be below the video. Now let's get to it. In the spring, I borrowed electricity from a neighbor. This saved me from buying a generator and hauling it to the construction site. Plus, even the simplest generator didn't fit in my small van. If there's an option to rent a socket, there's no need to look at a generator. A socket is always a much better, more convenient, and simpler solution than any generator. We got our own electricity a little later. There will be a separate video about bringing electricity to the plot, then to the building, setting up the electrical panel, tariffs, and wiring throughout the house. Subscribe now so you don't miss this upcoming episode. Our first visit was in March. The first tool, the first building material, and dreams of our own house. Remember this photo. By the end of the video, a 2-story house will be standing here. So we started with marking and digging a trench for the foundation. Since the house is rectangular, marking wasn't hard. A few pieces of rebar, a nylon thread, a little time, and the work plan was ready. The foundation would be 120 centimeters high. We dig 60 centimeters into the ground until we reach solid ground, and on 40 centimeters we'll fill in the yard later. The finished basement will be 40 centimeters high due to the first layer of aerated concrete blocks. This way the house wall won't get wet during rain or snow. I'll explain why later. We dug the trench in 3 days. It was hard but doable. While digging, we ordered a truck of sand and rebar with a diameter of 12 millimeters and rods 12 meters long. This is the maximum length for delivery. It allows fewer overlaps and a more solid foundation frame. We poured a small layer of sand, about 10 to 20 centimeters, into the trench, compacted it, laid bricks along the trench, and placed the rebar frame on top of them. My dad and I cut the rebar elements, and then, right in the trench, we tied everything with wire. The rebar was in 2 layers, 3 rods at the top and the same at the bottom. Vertical rectangles went at a frequency of about 1 meter. We completed the task in 1 day, thanks to all the preparation. As it turned out later, we assembled the frame incorrectly. There will be a separate video about my rebar mistakes. But surprisingly, despite the commentators' predictions, the foundation has been holding up a 2-story house for almost 10 years now. Everything's fine with it. Since we worked in the office during the weekdays and mostly entertained ourselves with construction on weekends, we started assembling the formwork the following Saturday. My mom and I assembled part of the formwork, and the next day we couldn't raise our arms. We decided to hire local guys who completed the structure. They wrapped the panels with plastic from the inside and fixed them with a stapler. It took about 3 days or 2 weekends. I also didn't forget about the embedded parts for communications. We used 50 millimeter pipes for electricity, intercom, grounding, etc. The 160 millimeter pipe was used for passing 110 sewer pipes through the foundation, allowing for adjustments. We poured the concrete directly from the mixer, and it was important to vibrate it. This helps the mass settle better and removes air from the concrete. The pouring went smoothly, but we did face one unpleasant moment. The formwork was slightly bulging in the middle. Conclusions: the formwork should be more securely fastened, and more care should be taken in choosing the workers who assemble it. This phase wasn't difficult. We poured the concrete in half a day. While the concrete was gaining strength, it needed to be moistened, so we quickly drilled a well. The well process was simple and quick. I called one of the contractors, met with them, pointed to the spot where to drill, and the next day they drilled it. It took a few hours. We ended up with a plastic pipe sticking out of the ground. The contractor easily completed the well installation. Roughly speaking, by the end of the day, we already had water on the plot.
Hello, water!
We visited after work and watered the concrete. The construction process was moving forward. A week later, we started dismantling the formwork and planning the next steps for backfilling. It's recommended to begin building the frame a month after pouring the foundation, as it will have gained enough strength to perform its main task. During this period, we planned to buy aerated concrete blocks and backfill the foundation. We threw the entire fertile soil outside the house and simultaneously found all the openings for utilities. I'll talk about the entire sewer system in the house, the experience of using it, its pros and cons, in the next episode. We're moving forward. For the backfilling inside the foundation, we used sand. Since the ground temperature under the house will always be positive, they often don't overthink it and backfill with whatever is cheaper. We did a photo shoot against the vegetation on the plot. These trees still don't know that soon there will be a lawn here. Yes, we backfilled the sand in small layers and compacted each layer with a vibro plate to ensure the backfill settles as well as possible. You could also water it additionally, but I think the vibro plate is sufficient. This will prevent future problems with floor settling. Cleaning up, we ordered aerated concrete blocks. A truck with a manipulator brought them and the truck unloaded them itself. The advantage of such a truck is that you don't need to separately order a crane for unloading and worry about coordinating the timing. It's cheaper for delivery and unloading too. We chose 30-centimeter thick aerated blocks for the walls, planning to insulate them with mineral wool, 5 or 10 centimeter thick. Now I'd simply choose 40-centimeter aerated blocks, make insulated reinforced belts and lintels, and wouldn't insulate the aerated concrete. 2 winters showed quite good results in terms of energy efficiency. Since the concrete reinforced belts act as a thermal bridge, at least 5 centimeters of mineral wool will be necessary. We start the walls with waterproofing. We do it without fail. Without it, mold and wall destruction are guaranteed, especially with damp soil. The first row, aligned with the level, keeping the building's diagonals, is laid on a cement sand mixture because we weren't able to pour the top of the foundation perfectly level. The aerated blocks are embedded within the house relative to the foundation. Now I would either make them level or let the blocks slightly overhang. This will allow proper insulation of the walls and foundation. There will be no step where water could collect after rain or snow. I won't go into too much detail on all the moments, as I already have a series of videos on building the house shell, where I describe everything in quite detail. The first row took the longest to lay because it was the first one in the house and also the first one in our practice. I remind you that almost all the work on this construction was being done for the first time in my life. Before this, I mostly just pressed buttons on a computer in an office. The next row and all the others were laid with adhesive. The masonry went at an incredible pace. After taking a week off, my friend and I completed the floor during that time. If you ask what I would build with now, my answer would be aerated concrete. I am sure about this choice. The process is quick, simple, and you get warm walls right away. Laying with adhesive, not foam or mortar. With mortar, the process is more labor-intensive, and the house will be colder. Adhesive foam requires perfectly level aerated blocks, and each row has to be perfect, otherwise cracks are inevitable. I tried to think through the project to the smallest details. Even the length of the walls is designed to minimize the number of cuts on the aerated blocks. I mostly cut blocks in half. This simple setup with an angle grinder and a table greatly sped up the preparation of blocks for laying. At the end of the workday, here's a small room tour. Our hotel, fridge, kitchen, a suite with fresh air, morning coffee, and the dawn. And so, we continued. 2 internal load-bearing walls were made of brick because several slabs of the floor will rest on them simultaneously, and on top, there will be the weight of the central part of the second floor. Another argument was that I planned to hang the kitchen on these walls, although now I realize that you can easily hang everything on aerated concrete as well. One more bonus is that these walls now act as a heat accumulator in winter. Also, we made 2 brick pillars at the entrance for the future balcony. I wouldn't do this now. The balcony could be welded from metal and visually thickened with foam. This way, the foundation wouldn't be needed. By the way, here's the foundation scheme we used. I would now make it simpler, saving time, energy, and material. Non-load-bearing partitions can be made from drywall without any foundation. In the boiler room, a partition is needed only if there is a gas boiler. I'm not 100% sure, but I think it's a mandatory requirement for gas services. The room with the stairs doesn't work for a boiler, so all the walls were erected. Now we lay a row of aerated blocks outside around the perimeter of the house, 10 centimeters thick, and inside we attach a 15-centimeter board from the formwork with screws. This will act as a form for pouring the reinforced belt. In the window and door openings, we lay a row of aerated blocks 10 centimeters lower. As a result, the reinforced belt above the walls will be 10 centimeters high and above the windows 20 centimeters. Reinforcement: 3 rods in one level along the walls and 2 levels in the openings. Here I also bent the rods at the corners as we used 8mm rebar, which bends fairly easily. Reinforcing the lintels on which the balcony slab will soon rest. We made small legs from thick wire so that the reinforcement would end up inside the concrete. We also used 16mm studs for future fastening of the roof to the terrace and garage walls. The reinforced belt goes along the central wall, making the entire structure of the first floor more cohesive. There is an opening in the wall. 2 ceiling slabs will rest on it, along with everything above. We made a massive beam, 25 centimeters by 30 centimeters. For safety, in addition to the rebar, we added a small I-beam inside. Also, in places where the vent channels will pass through, we built a specific structure in the walls made of foam concrete. It's easier to remove a piece of foam from concrete than to later create an opening in the reinforced belt for the pipe. We stocked up on materials and manually poured the reinforced belt in a day. Here's the floor plan of the first floor and our reinforced belt. Everything is on one level. The ceiling slabs are laid with a depth of at least 10 to 12 centimeters. The ends were laid on the walls. Between the slabs, there's a gap of about 3 centimeters at the top. If you look from below, the gap is minimal. In the future, this gap will be used to lay heating pipes. It's a good solution because, in this case, there's no need to pour a thick floor screed over the slabs. Time and money saved, less work, and the overall weight of the house is reduced. We, 2 people with no prior experience in laying slabs, completed this task in less than an hour, working together with a crane and a truckload of ceiling slabs. The crane also immediately lifted all the remaining pallets of aerated concrete to the second floor. Our work is not yet done. We continue building. Another row of 10-centimeter aerated blocks, and then we fill the gap with mortar. I'm not entirely happy with this joint and the reinforced belt. I would now try to improve it somehow using foam concrete to get a warmer interfloor slab. Although I moved the balcony slab away from the wall to leave space for insulation, these concrete beams will still be good bridges for the cold. Again, I'll say it's better to weld the balcony from metal or even build it from wood. A small photo session for history, me in the future kitchen. My mom at the future table. The second floor went faster and more neatly. The experience, although not vast, showed its value. The first row was laid with mortar, then it was all adhesive just like butter. We didn't forget to periodically reinforce our masonry. The factory didn't come up with that idea for nothing. We prepared blocks for laying in the openings below the reinforced belt. I was afraid they would fall off the reinforced belt. I was wrong to be afraid. Nothing would have happened to them. Tests showed that the block sticks firmly to the concrete even without that reinforcement. Studs for roof fastening. We're installing the vent channels in the kitchen. We mistakenly used a 110mm pipe. There are specific white 100mm pipes for ventilation. In general, it wasn't necessary to complicate things and could have been simplified greatly without laying all that brick. 4 internal partitions of 15 centimeters thick aerated blocks, I laid roofing felt. They say it helps with sound. Now I would use drywall partitions. Better sound insulation, faster and easier to build, thinner walls, no need for finishing trims when installing doors. The reinforced belt was only laid around the perimeter of the house. Ideally, I would have made a concrete strip here for the future roof beam. I didn't, but for even load distribution, it wouldn't have hurt. I have a crack in the wall here due to a heavy point load. Later, I had to redo this part of the wall completely to fix the situation. After pouring the reinforced belt, we laid the gables. Here, the aerated blocks were laid sideways. I didn't make the cut for the triangle because I didn't know the exact geometry of the slope. It's better to cut it before installing the roof. It's more convenient. The roof turned out to be the easiest stage as it was assembled for us. We just watched the process. The large height, quite a complex structure, and the impending frost motivated us to hire workers. 4 roofers assembled it in 3 full days. Of course, as with all hired workers, they made a few mistakes, but luckily not globally. Here's the result after 1 summer of work. 2 people with no experience in this field built most of it. So we're not claiming to be an encyclopedia on construction, we're just sharing our story. For more details on each stage, you can check the video link below or in the comments. Sewage, water, electricity, heating, finishing work, and practical experience of living in the house, all in the next videos. Subscribe so you don't miss anything. And to conclude, I don't like various cliches, but there's a saying, you should build a house, plant a tree, and raise a son in your lifetime. My parents helped with the first stage. I want to thank my parents for believing in me and supporting me in all my endeavors. Thank you so much for everything.